all have studied from our school days. Computer is all about a device that takes as input something and then gives you an output after processing. This is like the first definition that we all encounter when we first study computers, right? Let us take this definition and observe something. When you have an input to a computer, the computer processes that and then gives an output. The time that the computer takes to process depends on two things. One thing is, of course, the input itself. It's only straightforward to our common sense that if the input is bigger, computer will take more time. If the input is smaller, the computer will take less time to give you the input. So first thing is the input size. Second thing, first thing that makes your computer take more time is probably the input size. Second thing that takes your computer more time is the method that it uses to process. For example, if I give two big numbers, let's say 10-digit numbers, and ask the computer to add, the time that the computer takes depends on the method that it uses to add. And of course, if you increase the size 10 to size 100, your computer is going to take a little more time, rather a lot more time. So all in all I'm trying to say is the input size and the method that you use to compute matters a whole lot on the time that your computer takes to process and give you an output, right? It is important for us to understand the entire setup as a function f that we have studied in mathematics. You see, a function f is something that takes as an input x and gives you the output f of x. Discrete mathematics is all about seeing your computer as a function f and understand the amount of complexity involved in computing f of x, which is the output that is required. Sometimes the output depends a whole lot on the input size, and sometimes it's about the method that you use, and sometimes, rather most of the times, it's about both. So we must be able to compute and understand in our minds, rather calculate, have an estimate as to how many operations my computer will undergo before giving an input. Now, this is not an easy question to answer. If I want to sort a few numbers, let's say 100 numbers, how much time will my computer take? It's not easy to answer this question, but it is sort of easy to estimate the time that your computer might take. Right? So the subject discrete mathematics is all about understanding the number of steps that your computer is going to take, either undergo, before giving the output. There is some non-trivial math here. There is some math which is not so much aligned with the typical math of the 10th grade or 12th grade that we have studied. Something like calculus, trigonometry may not be of much use here. What comes in use is one's ability to count, precisely count and say what are the number of steps that a computer undergoes in sorting a bunch of n numbers, right? Depends on the method, as I told you, but then it also depends on some sort of a non-trivial math that goes in here before one concludes the total number of steps. So I welcome you all for this course. There's going to be a whole lot of discussions in different modes. One mode is I'll be discussing the way I'm discussing with you right now, and the animations will be going on by my side. There is yet another mode where I will do the chalk board way, except that I will not do it on the board, I will do it on my digital pen, and you will see me write stuff and then explain things in parallel. Mode 2. And mode 3 is I have a lot of my students coming here and there and helping you understand a concept with examples, solved exercises, They might even give you a puzzle or two to solve, or maybe even state some interesting facts, figures, and historical notes. Welcome aboard for the course.